Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic is Definitions and Terminology of Thermal Energy Based Process Part 2. At the end of this session, student will be able to understand the definitions and terminology of thermal energy based processes. Excuse me, here it may not be part 2, okay, part 1. Okay, right. First one is plasma arc machining. So before we discuss this one, at a glance, let us see the overview of this one. Okay, right. Now, plasma arc machining. Applications of machining. Okay, so in short, plasma arc machining, PAM, plasma arc machining. Applications of plasma for machining. Definition: uses a plasma arc to cut or etch materials. Okay, uses a plasma arc to cut or etch materials. Right. Process description. Plasma is generated by ionizing a gas and directing it at the workpiece, causing material to melt and be blown away. Okay, so in the process description, plasma is generated by ionizing a gas and directing it at the workpiece, causing material to melt and be blown away. Okay, so in the definition, uses a plasma arc to cut or etch materials. Okay, so here the plasma arc is using for the cutting the or removing the material, okay, through direct cut or etch. Right. Metal removing mechanism. Plasma generation, material removal. Okay, right. Plasma generation. High temperature plasma is created by passing an electric current through gas. Okay, so here how the plasma is generating. Plasma generation. High temperature plasma is created by passing an electric current through a gas. Okay, let us say here gas. Okay, what we are doing, we are passing an electric current. Okay, so plasma will be generated. Okay, so high temperature plasma here. Okay, high temperature plasma. Why? Because when an electric current passing through the gas, what will happen? The plasma will be with high temperature. Okay, right. Material removal. Plasma arc melts the material. Okay, plasma arc melts the material, which is then removed by the force of the plasma jet. Okay, so here the plasma arc first melts. Okay, plasma arc first melts the material. After that, this plasma jet forces to remove the material. Okay, so one is plasma arc, the other one is plasma jet. Okay, plasma arc melts the material, which is then removed by the force of plasma jet. Okay, so whatever it may be, the material is melting through the plasma arc, that is forcing out by the plasma jet. Okay, right. Right. Process parameters. Plasma temperature affects the efficiency and speed of material removal. Okay, so plasma temperature affects the efficiency and speed of the material removal. Okay, so that is nothing but rate of removal. Okay, next, gas flow rate influences the stability and focus of the plasma arc. Okay, so gas flow rate influences the stability and focus of the plasma arc. Okay, right. Cutting speed, rate at which the plasma torch moves across the workpiece. Okay, right. Process parameters, plasma temperature, gas flow rate, and cutting speed. Okay, one is plasma temperature, gas flow rate, and cutting speed. Okay, so in plasma temperature affects the efficiency and speed of material removal. Gas flow rate influences the stability and focus of the plasma arc. Third one, cutting speed, rate at which the plasma torch moves across the workpiece. Okay, right. Accuracy and surface finish. Right, surface finish and accuracy. See, always for any aeronautical or any engineering parts, components and products, and even medical or surgical parts and products, surface finish and accuracy, precision are very much important. Okay, so we cannot get the for all materials and for all material behaviors and their properties, we do not get good surface finish and accuracy. Okay, but with non-conventional technology or non-conventional methods, manufacturing methods, we can obtain good surface finish and accuracy and precision. Okay, right. Surface finish, quality of the machine surface affected by plasma parameters. Okay, next, accuracy, precision of the cut influenced by equipment settings and material properties. Okay, so let me reiterate surface finish and accuracy. Okay, quality of the machine surface affected by plasma parameters. Okay, so the quality of the machine surface depends on the plasma parameters. Okay, so what are the parameters? Plasma temperature, gas flow rate and cutting speed. Right, now come to the accuracy. Precision of the cut influenced by equipment settings and material properties. Okay, right. Applications and limitations. Used for cutting thick metals and conducting precise work in industries such as shipbuilding and manufacturing. Okay, so this method is particularly suitable for shipbuilding and manufacturing. Okay, and limitations: high energy consumption, potential for material distortion and precision for fine features. Okay, sometimes these non-conventional machining processes have also some limitations for particular scenario or particular regions where the precision of fine features are required. Okay, Right, once again, let us look at this applications point. Use it for cutting thick metals. Okay, even thick metals can be cut by using this process. Okay, chemical machining. Right, plasma chemical machining. And conducting precise work in industries such as shipbuilding and manufacturing. Okay, so here plasma arc and plasma jet. Okay, so plasma arc melts and plasma jet flushes away, just like in the previous process. Okay, the dielectric medium played that flushing out now. So see here, here similar to that, here plasma jet blow out the remove material from the workpiece. Next, limitations: high energy consumption, potential for material distortion, and limited precision for fine features. Okay, so limited precision for fine features. See, sometimes definitely we'll have some limitations with this plasma arc machining, whatever it may be. Okay, right. Key terminologies: plasma arc, high temperature ionized gas used for material removal. Okay, high temperature ionized gas used for material removal. Next, gas flow rate. Rate of gas supplied to the plasma torch influencing the arc stability. Okay, plasma arc, high temperature ionized gas used for material removal. Gas flow rate. Rate of gas supplied to the plasma torch influencing the arc stability. Okay, so these are the key terminologies. Okay, next, chemical machining. Okay, right. Principle, definition, process description. Uses chemical reactions to selectively remove material from a workpiece. Okay, uses a chemical reactions to selectively remove material from a workpiece. Okay, right. Process description. Workpiece is immersed in or exposed to a chemical agent that dissolves material. Okay, so in chemical machining, so principle, definition, uses chemical reactions to selectively remove material from a workpiece. Okay, and process description, workpiece is immersed in or exposed to a chemical agent that dissolves material. Okay, next, muskets. Definition, materials used to protect areas of the workpiece from chemical etching. Okay, so similar to the previous process as we discussed earlier, here muskets play the same role. Okay, materials used to protect areas of the workpiece from chemical etching. Right. Types: liquid muskets, tape muskets, and photoresist materials. Okay, so here materials used to protect areas of the workpiece from chemical etching. Okay, that is musket. Okay, the musket types may be liquid muskets or tape type or photoresist coatings. Okay, right. Applications and limitations of this chemical machine. Applications: used for etching and patterning in electronics and aerospace applications. Okay, right. Limitations: limited to specific materials and requires careful handling of chemical. Okay. Next, key terminologies: etchant, muscat. Okay, I think already we have discussed this one just now. Okay, before we conclude, let me summarize. Okay, applications of plasma for machining. Definition: uses a plasma arc to cut or etch the materials. Okay. Process description: plasma is generated by ionizing a gas and directing it at the workpiece, causing material to melt and be blown away. Okay, right. Next, here metal removal mechanism is an important one in all the process. Okay, the main machining process is for the removal of the material. Okay, so we have to study its mechanism very carefully. Okay, so how the material removal mechanism is depending on the various parameters. Okay, that is very much important. We have to study and we have to research on those things, and we have to constantly implement and improve the technology to adapt some feature to the existing one. Okay, right. Plasma generation. High temperature plasma is created by passing an electric current through a gas. Okay, and material removal. Plasma arc melts the material, which is then removed by the force of the plasma jet. Okay. Next, process parameters. Plasma temperature affects the efficiency and speed of material removal. Okay. Next, gas flow rate, okay, which influences the stability and focus of the plasma arc. Okay, right. Next, cutting speed, rate at which the plasma touch moves across the workpiece. Okay, so let me reiterate these things, very important. Process parameters: plasma temperature, gas flow rate, and cutting speed. Okay, right. Accuracy and surface finish. Surface finish, quality of the machine surface affected by the plasma parameters. Okay, and accuracy, precision of the cut influenced by equipment settings and material properties. Applications, see here, particularly this will be applicable for the shipbuilding and manufacturing. Okay, and some limitations are also there. High energy consumption, potential for material distortion, because this is high intensity plasma. Okay, high temperature plasma, and limited precision for fine features. Okay, this is one of the negative issue. Next, plasma arc, high temperature ionized gas used for material removal. So this high temperature ionized gas will have both positives and negatives. Okay, so that may be one of the limitations too. Right, chemical machining, already we have seen. Okay, 2 times, no issue. So here etchant means chemical solution used to dissolve material during the machining process. Okay, and muscat is just a template which can be fixed over the surface of the workpiece, where the material removal not to be done. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.